This is the only long-term information that we have from the surface of the moon.
I don't think the search for data is over with.
Where did all of this stuff come from? How did it form? What was the process? Does it happen all the time across the universe? Or are we somehow unique or at least unusual? What does it all mean?
I'm Katie Atkinson, and this is NASA Explorers Apollo, where we tell stories about our moon and the people who explore it.
Tape recorder's running, right? Tape recorder's running.
50 years ago, NASA's Apollo program brought humans further into space than we'd ever gone before. On July 20th, 1969, astronauts Neil Armstrong and Buzz Aldrin trekked the surface of the moon for 2.5 hours. The Apollo 11 crew would spend about a week in space. But us? We're still learning. By all appearances, scientific discoveries seem to happen in an instant. We often forget that science progresses slowly, quietly inching us towards something meaningful. We pick up pieces of information over decades, try to make sense of them, and then venture into a new set of mysteries to untangle. It takes time. For the Apollo program, at least half a century. And we're not done yet. The moon still has plenty of unanswered questions for us.
Prepare it for liftoff. T-minus 1 minute, 35 seconds on the Apollo mission, the flight to land of the first men on the moon. All indications coming in to the control center at this time indicate we are go. 1 minute, 25 seconds and counting. Our status...
During NASA's Apollo program, 6 crews of astronauts landed on the moon. During those visits, the astronauts set up what were called lunar surface experiment packages. There were heat flow experiments, solar wind spectrometers, ion detectors, instruments that studied the moon inside and out. These scientific experiments gathered massive amounts of information and sent it back to Earth. But the thing about that data, a lot of it was misplaced. Dave Williams is on a mission to track it down.
I work on a lot of the older Apollo data, which is really sort of incomplete. Unfortunately, towards the end of the Apollo program, a lot of the data were just archived away and weren't really looked at. And the other problem is that back in the 70s, the data were archived on things like microfilm, microfiche, that were really almost inaccessible. This is the only long-term information that we have from the surface of the moon, are these data. There's just nothing else. And so we decided if we really wanted to know about the moon, we were going to have to restore these data.
Dave is a scientist at NASA's Goddard Space Flight Center in Greenbelt, Maryland. He's also a data detective. Dave's job is to find, digitize, and archive lost data from the Apollo era so they can be used by researchers for generations to come. Uncovering these data could help scientists make new discoveries about our moon, as we plan to send humans back by 2024. But tracking down the information is an incredible challenge.
There wasn't a lot done with these data. So when we went back to them, we really had to kind of dust these things off. You know, a lot of those things you just can't figure out by looking at them. And so we had to go find old documentation. We had to try to find the principal investigators or the other scientists who worked on the experiments or technicians who built the experiments and find out from them how the things worked and how the data were returned and that sort of thing.
When he began his search for data, Dave approached scientist Patrick Taylor to ask him and his colleagues what needed to be saved.
Well, we looked at each other and we said, look, when they went out with that mission, each instrument, each program was very highly reviewed and vetted. They're all good. They're all important. You can't just rate them.
That's Pat. He's a NASA scientist who thinks that every bit of data is an important piece of the puzzle. Dave's restoration of old heat flow data, for example, helped Pat make a new discovery about our moon.
So while we didn't have a lot of data, we didn't find a lot of data. We found enough to confirm that the lunar surface underneath the surface was heating up instead of reaching equilibrium temperature.
The restored data allowed Pat and his team to study the transfer of heat through the moon's surface and subsurface. They learned that the moon is a little bit more active than previously thought. When the Apollo astronauts trekked across the moon, their footprints disturbed the moon's surface, changing the way it absorbs and reflects light and heat. Knowing how heat moves through the moon helps us figure out how it formed, how it evolved, and what it's made of.
So the heat flow tells us, is the moon dead, or is it alive? How much is it alive? What's the distribution of radioactive elements in the near surface? And our data showed that if you disturb the structure on the lunar megalith, you change its albedo, you'll change its thermal history. When we go back to the moon with robotic missions, the heat flow instrument has to be designed so as not to overly disturb the surrounding area where it's going into the hole. So in that regard, our work is important for future missions.
And according to Pat, the hunt for data is far from finished.
I don't think the search for data is over with. There's got to be more data out there. The moon has still got a lot of secrets it's keeping.
To find those secrets, Dave and his team look for first-hand sources. The people who were there during the Apollo era, and can help shed some light on what was collected.
And luckily, there were still an awful lot of people around from the Apollo days who still remembered this stuff, for one thing, which I find amazing. I mean, I try to figure out what I was doing 2 weeks ago, and these guys are remembering what they did 40 years ago.
Sometimes Dave's research involves making house calls. In 2016, he and his team visited a man who worked at NASA during the Apollo era, a man named Otto Berg.
He was a principal investigator for one of the instruments, but we did get hold of him, and we talked to him, and he said, oh, yeah, he had all these detailed notebooks, and if we would like to look at them, we could come visit him and take a look at the notebooks. Now, this fellow was 90-something years old, and we called him, the day before. He said, well, I've just got out of the hospital. I've been really sick. I'm not feeling well, but you could still come up, but I may not be able to talk that long. We went up, and sure enough, he did look, he looked a little sick. He looked a little tired. He brought out his books, and he started talking to us.
Otto worked on an experiment that analyzed cosmic dust from the moon's surface.
While he was talking to us, you could see him suddenly start to lighten up. And then he just kept talking and talking about his experiment, and he just seemed like he was just getting better and better while he was talking about it. We ended up being there for like 2.5 hours talking to him about all this stuff. And then he ended up lending us his notebooks, his personal notebooks, so that we could scan them. They were really beautiful notebooks. I mean, he had written down everything really carefully. He had made graphs, all different colored pens he'd used to highlight different things and stuff. They're really quite something. And we scanned every one of them, and now I feel like all this stuff is completely saved forever.
Otto Berg passed away in January of 2017. He was 99 years old. The work that he dedicated his career to is now free and accessible through the National Space Science Data Center for anyone who wants to learn more about Earth's closest neighbor. Thanks to Dave's team, current and future scientists can use information like this to paint a more detailed picture of the moon. Data from the Apollo era gives us a window to the past, as NASA plans to send astronauts back to the surface of the moon in the near future. Data collected with today's technology, combined with information preserved from the Apollo program, places us at the edge of new discoveries.
In so many ways, this is really the golden age of understanding our solar system. There's all sorts of these amazing missions out there now that are returning data at rates and with instruments that we couldn't have even dreamed of 40 years ago. NASA is still here and probably doing more for science and for understanding of the solar system and the universe than ever.
Everything we collect, even the scribbles of a personal notebook, helps scientists learn more about our moon, furthering our understanding of the universe. We asked you to help NASA tell the story of Apollo. Hundreds of people answered, from all over the world. Here's what Katon from Sugar Land, Texas remembers.
My memory of the Apollo moon landing is probably going to be very different because I was not in the United States. I was a 5-year-old child in Mumbai, India in 1969. We did not have a television. We did not see the event live. My family and some family friends, we all saw the event a few months later, probably October or November 1969. My dad heard about the United States having sent a man to the moon, and he wanted to give his children a first-hand look. He got the film on loan from the United States Information Service, hired a technician, rented a projector, and invited his nieces and some friends. We all saw the film together projected on a wall in the living room. The wall must have been about 10 feet wide and 12 feet tall. It was painted white, and all the picture frames and decorations were taken off for the film projection. I clearly remember that was the day when I fell in love with everything associated with America. The country, the people, the inventions, and NASA. My deep interest in science is partly because of that film. Thanks, NASA, for everything.
Thanks, Ketan, for sharing this story with us. What do you remember about Apollo? Or what space exploration do you hope you get to see in your lifetime? NASA wants to hear your Apollo stories. Visit nasa.gov/Apollo stories to learn how to get involved.